everyone. So welcome back. So today we'll be going through some more state-of-the-art stuff for transformers. So if you recall, just sort of a recap from yesterday, we spent some time just playing around with different AI models and sort of getting a feel for the different tools that they have. So now that you have sort of a feel for the tools, we'll be discussing some more interesting stuff that you can actually do with the tools, right? And so people have built sort of really cool stuff you can do now. A lot of this stuff has not really entered the mainstream yet. And so you'll sort of see stuff that is very much still in the research phase. And even honestly, companies haven't been built around these tools yet. And so, you know, it's sort of like an open field for you to build companies or to do interesting research in. And some of these ideas are sort of a little bit older than others. So, you know, for example, like prompt engineering and some memory stuff is now starting to define corporate strategy quite a lot. Like a lot of companies, a lot of hospitals are starting to look at these tools. But then things like AI agents or text to action is, you know, in my opinion, probably going to be like the next billion-dollar companies. And, you know, some of the tools are already available there, but no one's just sort of built tools or built companies with it yet. So we'll be discussing some of those later as well. Now, LLM security is another really important issue that we'll sort of almost you know, discuss at a very superficial level, just because we have someone who's a lot more experienced coming in to talk about it next week. But just sort of to give you a bird's eye view of what's happening in LLM security, because honestly, like no one's really thinking about it, right? Like hospitals aren't thinking about it, companies aren't really thinking about it, but they should be, right? Because you can really hack these LLMs quite easily right now. It's cool. So before all that though, we're actually going to go through just a little bit more basics in terms of advanced stuff. It's sort of funny, but like basic advanced stuff. We're going to be talking about, to start off with today, just how to actually think about transformers, right? Like, because this is sort of a massive paradigm shift, and actually people struggle to think even, you know, at the exec level or whatever, about how to actually think about transformers, like how to actually think about these magical tools that we currently have, and also to how to think about the future of transformers, right? Because there's like very clear trends that we've now learned over 50 years of AI, and so how to think about AI is like a really sort of useful tool to have in the back of your mind just as you continue into this field. We'll then also talk about alignment and different architectures. So alignment is that, you know, that thing of orienting the model to fit human values, right? So how do we actually do that? That's sort of at the small level. So micro scale is like, you know, just making sure that the model responds in a way that's useful to us. But at the macro scale, it's making sure that, you know, AI in the future doesn't destroy humanity, right? So it's sort of like, you know, in between, you know, anywhere in between that. And so if you're interested in that, there's lots of different resources you can look for alignment. None of us are experts in alignment. We have to study probably for another, at least like several years, slash even a few months, if just to get sort of the basics of it. We'll talk about different architectures. Like I said yesterday, you know, lots of different architectures are still appearing on the scene. We haven't sort of had the final say yet that GPT is the best forever, right? It's the best for now. But you know, people are starting to ask the hard question of like, how can we improve GPT, right? There's all these weird and wacky ideas that are happening. And then we'll run you through some more basic stuff here that you know, AI companies are already starting to deploy, like prompt engineering, which is how to craft AI to work the way you want it to work, right? And so that's even just a useful skill to have. You know, Paul and I were just talking, like we've previously done prompt engineering stuff, and she uses prompt engineering when she's using AI, right? Like you just use it in your day-to-day because you know that it works better, right? And then we'll talk about another field, and I don't know if we'll get to this today, so we also have some time on Thursday to cover some of this stuff as well. But there's a really cool and exciting field called mechanistic interpretability, which is a really fancy word to say, how do we explain what's happening in the AI, right? And as you can imagine in medicine, really important, right? Because you want to understand how the AI got to its conclusion, right? Like the AI might be like, well, this patient has colon cancer, and you're like, how on earth did you get to that conclusion, right? And so there's all sorts of cool techniques these days where we can basically get into the soul of the AI and then figure out what's happening, right? And so we'll run you through, and we'll actually have a demo as well, which Deepak will run to show you actually how these models sort of work, right? Like if you steer it in this way, how does it work? If you steer it in this way, how does it work? And they're actually a lot more malleable than we expected. And so sort of a really exciting field to be in right now. Okay, so let's just jump straight into the transformers. So how to think about it. Let's see if this works. Okay, so a big question that a lot of people have been asking is, can we predict the future of AI, right? And honestly, if you can answer this question, you probably can create like, you know, trillions of dollars of value, right? And the answer is pretty much not in the short term. So you don't know exactly what's going to happen in the next sort of 5 to 10 years, but maybe in the long term, right? And part of the reason why is that there are essentially dominant forces in AI that people have recognized over the last 50 years, right? So there's just a couple of dominant forces that keep on popping up and again every time we see an AI summer, right? And so what are those forces? They're not sort of rocket science or anything. One is compute, so the ability for us to compute stuff, like actually run mathematical calculations, is pretty much doubling every 2 years, right? And so that's a law called Moore's law, right? So Moore was one of the founders of Intel, and he basically predicted that every 2 years, the computational capacity that we have just doubles. It just simply doubles, right? And so far it's held since the 1970s, right? And every few years someone's like, Moore's law is breaking, but it hasn't broken yet, right? Maybe it'll break in future, I don't know, right? But so far it's held quite well. At some point, and I was talking to one of my friends who works in sort of, at Intel actually, about this, and he was saying that at some point you do reach like a limit in terms of the chip size that you get, because it becomes like at the atomic scale, right? But we're not quite close to that yet. Maybe in like 10 years, 20 years, we'll sort of get there, and then they sort of have to figure out a way to get around that, and maybe quantum physics is good enough that we can figure out a way to get around that. But right now we sort of don't have, there's no sort of like hard physical barrier until that point where, a transistor gate is just an atom, like a few atoms, right? So we're not quite there yet. But yeah, so what this basically means is that, and this looks like a linear line, but actually this scale here is exponential, right? And so what we're basically getting is an exponential increase in compute, right? Because it's doubling every 2 years. So that's an exponential equation, right? If you think about that. And so that's one of the sort of key dominant forces, okay? So one is compute. And then two is the amount of data we have, right? And so this also seems to be increasing exponentially as well in terms of how much data we're just simply collecting, right? Like whether it's, the internet, like Facebook posts or Reddit posts or TikTok videos or whatever, like the amount of data we're producing, right, seems to be increasing as well. And so these two factors are exponential, right? And so because they're exponential, sort of everything else, doesn't really matter as long as it's not exponential or sub-exponential, right? So it's underneath sort of an exponential equation. And so with those two, this has led to what's known as the sort of scaling laws that we're seeing right now with large language models, right? And so not directly sort of related, but somewhat. And basically this scaling law was published in 2022, and this paper as well, 2020. And it stated that AI performance seems to be a predictable, smooth mathematical function based on two variables, right? One is the number of parameters, so the model size that we have. That's obviously directly related to how much compute we have, right? Because larger models require a lot more compute. And then the second is the amount of data the model is actually trained on, okay? And so that is one of the reasons why a lot of AI companies these days, people are just simply throwing money at it, because if you can increase the model sizes that you have and the amount of data you have, it seems to just perform better, right? So the AI just keeps on getting better and better, right? Based on the loss function that we currently have, right? Which is perplexity, right? And hopefully you've run through perplexity last week. So there are no signs that the function will top off yet, right? There's always arguments that maybe at some point it becomes sublinear, right? But so far it's been demonstrated across 7 orders of magnitude. And so it's been sort of an equation that's actually held quite reliably for large language models. So in other words, and this is just a fancy way of saying it, for large language models there are 2 things that matter. One is the model size, and 2 is the amount of data you train it on. If you keep on increasing that, the model will always do better. It will just keep on doing better and better, okay? So a very sort of interesting thing to see. Now, what does this mean in terms of other heuristics, right? So smaller models generally tend to memorize stuff and they rely on simple rules to get by, right? While larger models seem to have more complex heuristics and can manage to deal with what's called tail knowledge better. Tail knowledge is just a fancy term for rare knowledge, right? Like stuff you rarely run into, right? In terms of things like large language model depth and breadth, obviously increasing this allows the model to perform a lot better, right? And so the model is, if it sort of increases in size, is able to draw deeper and deeper connections, right? Connections that even humans might not be able to see, right? So a sort of basic neural network might see sort of first or second order connections, but then as you increase, it might be seeing like 100th order connections. So like really deep connections between things that humans can't even perceive. And so more data, more compute just simply means stronger AI. And so the first exercise is actually to read through this paper, right? And I'm hoping this link works because I created it a few months ago. And actually read through it. So we're going to spend some time reading through it right now. And then I'll get you to, after you finish reading it, to actually discuss with your neighbor what your thoughts are on this paper. And take your time in this paper. This is a paper that honestly I read like every few months or every year, right? Just to sort of remind myself about some of these sort of long-term trends that we're seeing. Let's just sort of recap what we learned from the bit of lesson, right? Actually, let me just record. Okay, already recording, great. So the dominant forces in AI right now are data and compute, right? And you can really demonstrate it mathematically, almost like if you have something exponential, right? If you have other variables which are linear or anything that's sub-exponential, it doesn't matter in the long run, right? Like when you sort of move hundreds of years in advance, data and compute are still currently the dominant forces, right? Building our own knowledge into AI helps in the short term and is very satisfying for ourselves, but does seem to inhibit future progress, right? Unless you can sort of keep your eye on data and compute being the sort of powerful things. Breakthroughs seem to arrive by scaling computational and data with general purpose learning methods, okay? So you sort of really need to look inwards and think about how humans learn, right? And we had the discussion as well, like, you know, humans might not be the best learners either, right? Maybe some alien species comes down and teaches us way better ways of learning stuff. But right now we sort of have these main things, which is, you know, mathematics, things like attention, search, learning, like what other stuff is general purpose, right? It could also be maybe discovery, right? Like I'm just thinking AI doesn't really have a curiosity mechanism, right? Curiosity is a really powerful thing for learning for humans as well. And why? The world in our minds are tremendously complex, right? Like just think about reality, right? It's just really complex. It's almost like irredeemably complex, right? We don't understand why. Like biology is, for example, irredeemably complex, right? Like the body is just absolutely crazy, right? And humans imperfectly understand it, right? Because we have limited amounts of information that we can store in our brain, right? And so we always rely on heuristics when we're sort of dealing with this stuff, right? And so we don't want to pass too much of those heuristics down to AI. Side note, and I've mentioned this before, but AI gets easier to teach and to learn, the better it gets, right? And because and the reason behind that is because AI gets simpler, right? Like we're removing restrictions from what we're giving to AI. And so if you can, and this is if you ever decide to go into AI research or just think about these problems, you know, if you can avoid adding your own assumptions, you know, and think about how you can enable general purpose learning. Now, sort of related to this is a sort of interesting challenge I saw last year, or earlier this year rather, whereby someone was like, you know, GPT sees 1.4 trillion words during training, right? That's a huge amount, and I think this number has increased now, right? But a 13-year-old has seen 140 million, right? A 13-year-old child, right? So 0.01% of what GPT sees, right? Which means that humans are a lot more efficient, right? And so it's sort of like, you know, if I had read 1.4 trillion words, I'd be way smarter than ChatGPT, right? And so a big question is, you know, what are we missing, right? So transformers right now equals neural networks plus attention, right? And I actually sort of don't like the slide as much recently because this plus here is actually conceptually wrong. It's almost a subtraction, right? We're allowing the AI to decide what it wants to pay attention to. So we're removing a restriction, you see? So I sort of do this just because it's easier to understand, right? But we're actually enabling the AI to do something. So we're removing a restriction, right? And so what else can we remove? What other restrictions can we remove, right? And so the next architecture is sort of upcoming, and I don't know if it's next year or in 10 years or 20 years or whatever, right? But what is the thing we need to remove? Or what is the capability we need to provide to AI? What are we missing here, right? And so I'd like you to actually discuss with your neighbors what you think is missing, right? And I want you to look sort of inwards. How are you as a human learning? How is society learning in general, right? What sort of capability can we add into AI? Okay, so I'll give you a few minutes to discuss that. Right. And so, I mean, just some ideas that thought of before. Do humans have innate knowledge in some way, right? When we're born, right? Like, you know, when a horse is born, for example, it already knows how to like walk, right? Right? Like, or does a human have some sort of innate knowledge when we're out, right? Probably. If you think of the reflexes that humans already have, for example, right? Multimodal grounding, we talked about spatial computing, right? Like, what does it mean for AI to have access to a lot more sensors, right? Do they even need that sensors, right? Like, you know, maybe it's like carbon dioxide in the air or, you know, whatever it is, right? Active social learning. So humans are inherently social creatures, right? Does the AI need to grow up in a community of some sort? Maybe a community of other AI? I don't know, right? That's just ideas. Do we have the wrong optimization thing? Do we have the wrong loss function, which currently right now is perplexity? Perplexity is very built for language, right? Is it great for other stuff? I don't know. Flexible hierarchical learning. You know, we've shifted towards statistical learning for these models, but humans, we sort of still rely on heuristics quite a lot, right? And it's a lot more efficient to rely on heuristics, right? So if we swung the pendulum too far, you know, towards statistical learning methods. Adult abilities. So I'm just thinking like, you know, so that was child abilities. Adult abilities, you know, continual learning, curiosity, infinite external memory, right? Like some way to do that idea that we just discussed. Self-improvement or reflection. So the ability for the AI to reflect on its own answers and its own experiences, whatever that may be, right? There was this sort of funny thread on one of the forums discussing Claude, and you know, they were just saying that this AI seems to have much more reflection than we think, right? Like if you ask it about its own experiences, it's probably regurgitating a bunch of stuff it thinks, right? Like, or it's seen on forums or whatever, right? But it almost sounds a little bit human-like when it's reflecting on its own experiences as an AI, right? It's a bit funny. Emotional and social understanding, right? Like, what does that mean? Ethical reasoning, how important is that, right? Should it have the ability to self-improve or self-fine-tune in some way? So sort of all big questions. Now, some sort of more practical, like sort of advice, right? Or practical sort of information, actually. So although learning itself is quite smooth in aggregate, right? So, you know, just back to this graph here, which is the scaling law, which is as you give it more data, more compute, or more parameters, then the AI just does better overall, right? In an exponential manner. Depending on the task, it actually doesn't have the same pattern, okay? So depending on specific tasks, it does not have the same smooth pattern. So some researchers at OpenAI did this really interesting study whereby they basically provided 202 different tasks, right? So some of them, for example, like, you know, question and answering, summarization, or whatever, different types of tasks, right? And they found that 29% of tasks have a smooth curve, right? Whereby if you increase the compute, then the performance of that task gets better. Okay, it just gets better linearly. Interestingly, 33% were emergent. So that is, the AI model does really poorly for quite a long time, and then suddenly it starts getting better. Okay, so that's an emergent task. So a third of tasks are emergent, right? So for some reason it does really poorly, like you have a small language model here, it just does really poorly, and then it just suddenly like figures it out, right? Really unclear why. 22% are flat, so there's 22% of tasks, it just never learned it, right? And it's unclear if that flat just simply means that it's gonna stay flat or it hasn't reached the emergent point, right? Like we're just sort of seeing this section of the graph, okay? 2% for some reason had inverse scaling, so it got worse as you increased how much you were training the data, okay? And so there's all sorts of theories about why on earth that happens, but it's sort of an interesting phenomenon, which is some tasks, it just keeps on getting worse and worse and worse. The more you train it, the bigger model you have, okay? And then 13% were not correlated at all in any way, okay? Yeah?
Do we know what kind of tasks those 2% are?
I think we do. You can read the paper. Yeah, I don't remember it, unfortunately. But yeah, so very interesting, right? Like different tasks have different learning abilities, right? And I can't recall if I have a slide on it, but there's this concept called grokking, which is why like Elon Musk called his AI model grokking, or grok rather, whereby you basically, like the model just like you know, really does poorly and then it suddenly does better at a certain point, right? And you can actually show that the model for some reason, if you overfit, so you know how we've been talking overfitting is really bad, right? Just keeps on getting worse and worse. If you bring that overfit, so a lot of people have tried like overfitting the model to an intense degree. Like you keep on overfitting like 10 times longer than you should have. And then for some bizarre reason, it just suddenly clicks and then it learns it. Right, so that's called grokking. We don't fully understand why that happens. It happens for some things and not others, right? But for some specific tasks, if you keep on overfitting the model to an intense degree, then everything just clicks and it learns it. Okay? So that's also another strategy that is sort of upcoming and people don't understand fully yet. Okay, now how should we perceive AI conceptually, right? And so conceptually, AI can be thought of as multiple things. The first is as a prediction or generation tool, right? And so hopefully you're already familiar with this concept. You know, when AI is generating text or images, that sort of thing, it's a generation tool, right? Or it's trying to predict the end of a sentence that you're providing it, or the answer to a question, right? So prediction itself is very powerful, obviously just not only for language, right? But also for things like videos, right? Have you seen this tool before. So it's a tool called Sora. It's released by OpenAI, and this is actually an AI-generated video. Okay, and I mean it's not complex. You've played around with images now, right? Videos are basically just a bunch of images strung together, right, with time. And so yeah, also useful for images. Also very useful for things like protein prediction, as we've talked about now, and hopefully you're a bit more familiar with now. So predicting what proteins look like from an amino acid sequence. Concept 2 is that AI is very powerful as a world modeling tool, right? And part of the reason is that during pre-training, we are providing it a lot of information, right? And so it builds an understanding of what our world looks like, right? And so because of that, it has concepts like the Golden Gate Bridge in its like weights, right? It understands what the Golden Gate Bridge is in different languages, right? It recognizes it. It also seems to recognize it in image format as well, right? So it has an understanding of what, for example, the Golden Gate Bridge is. And so this is a very small image that I put here, but someone actually tried to pull into Claude, right? Like one of the leading AI models now, and draw a map of different immunology concepts, right? And as you can see, like it actually places immunology concepts that are similar to each other in a similar space, embedding space, right? So for example, like common diseases are here, immunocompromisation is here, vaccines and immunizations here, and I've cut it off, but legal immunity is even beneath that, right? Because it's considered conceptually similar, but obviously a different thing, okay? Now we'll actually get to play around with this later, but it is possible right now, as of the last 3 months, to actually up or down adjust different connections and features, right? So it's sort of a very cool feature to have. Concept number 3 is that AI may be a very powerful hypothesis generation tool. So we just talked about it before, right? But because the AI learns so much in its world model, there are questions as to whether it's seeing stuff that we do not understand yet, right? And how do we actually pull that knowledge out to provide hypothesis so that we can actually do research and actually prove whatever connection it's seen. And so there's actually been some movement on this, a little bit, right? Not as much as I thought there would be. But there was this really interesting paper here whereby these authors here basically put in a ton of transcriptomic data, okay? So transcriptomics, right? And the AI actually learned to structure these cells based on cell lineages by itself, right? And quite interestingly, it also discovered a new type of cell that was only discovered last year, right? So it had its own little island for a cell that created EPO, called the NERN or NORN cell in the kidney, right? And it discovered that that was its own separate cell, right? And so that's just a sort of simple example of AI trying to figure out, or AI generating this new knowledge that we can use as hypotheses, okay? So sort of a very interesting space to watch. And it's sort of linked to this idea that, and I think a couple of people said this now, the next great scientific theory is hiding inside a foundation model, okay? It's hiding inside the large language models we've built because they're seeing connections that we cannot see. Okay, so that's transformers. So that's sort of the theoretical component of it. So now we'll talk about alignment, okay? So alignment, broadly defined, is making AI aligned with human values, okay? Whatever that might mean, okay? So human values, obviously, different per person, different in different societies, right? But more broadly, just with human values. And generally, alignment right now encompasses fine-tuning activities. So we're using fine-tuning as a method to make sure that AI is aligned with human values, right? That might change, obviously, in the future. We might have completely different methods or more effective methods or something, right? But right now, it's mostly fine-tuning. And there's lots of different types of alignment, right? So for example, there's safety alignment, which is training a model to act safely, right? There's instruction fine-tuning, which is training a model to follow instructions. So when humans provide instructions, then it learns what to do. There's preference fine-tuning, which is training a model with labeled preference data in particular. So that is, I prefer this response over this response. AGI alignment is another field, right, that some people spend their whole lives on, which is alignment of super intelligent models. So what happens if we have a hyper intelligent or super intelligent model, right? Because we need to figure out that before we have a super intelligent model, right? So we need to sort of preemptively figure out what we should be doing, right? And there's lots of other types of alignments, right? So just think about what other things you might want to align, right? So sometimes it's medical ethics, sometimes it's laws, for example, right? It's like there's all sorts of different types of alignments. So we're going to talk a little bit about safety alignments. So right now there are two primary approaches. The first is something called LLM as a judge. Now we've chanced upon this concept before in evaluation, which is using a large language model to evaluate how well another AI model is doing, right? But you can actually also use the same concept to decide if the AI should respond to this question, okay? And so ChatGPT and Meta, so Llama, right? They both use the LLM as a judge concept, right? Whereby they actually have, so every time you use ChatGPT, they have another AI in the background that assesses the response assesses what you've asked and how the main ChatGPT should respond, right? And it decides whether it should or should not respond. Okay, so I'm sure you've asked stuff like, someone was trying to create Asian Elon Musk yesterday, right? There's a second AI that's like, no, you should not respond to that, right? And so therefore, that is a banned content. Does that make sense? Okay, so there's a second AI sort of in the loop there. Llama is the same thing, but it's a bit more advanced. It actually tells you how you're breaking the rules, right? So it actually tells you, this is something that's racist, or this is something that's sexist, or whatever. So it tells you how you're breaking the rules as well. So that's the LLM as a judge concept. Now, Claude actually does not use that, okay? So they actually use a slightly different technique called self-improvement or constitutional AI. And actually, I have another slide for LLM as a judge here. So yeah, so this is just what I've said here. LLM as a judge is Meta or OpenAI using a strong LLM to decide whether the question should be answered, and in Llama's case, what types of harm the question might have. Now, for constitutional AI itself, it's very interesting, but Claude basically provides a list of human-crafted rules or principles to the system, right? And then the large language model learns how to uphold this via steady human feedback. Does that make sense? So instead of having a second AI system, you basically provided a bunch of rules, right? And then humans craft its behavior over time. Okay, so it's a little bit more similar to the preference fine-tuning, right, conceptually, but for safety reasons. And quite interestingly, Claude actually released in August what its constitution actually says. So you can actually read the whole thing, and it's really fascinating to read about it. It's about 2 pages long, right? And I sort of recommend you to, if you have spare time, to actually read through it and see how they're crafting their AI system, right? But this is just a little sort of snippet of it. So it's like the assistant is Claude, created by Anthropic. The current date is blah, right? Claude's knowledge base was last updated in April 2024. So you see how one of the first things it says is when it was last updated, right? Which is one of the reasons why, if you ask about recent events, for example, Claude will be like, hey, my cutoff is April 2024, so I can't answer anything that's happened after that, okay? And then blah, blah, blah. Claude cannot open URLs, links, or videos, okay? So if you try to provide it like a YouTube video, it cannot open it, right? And it'll say so, right? See what else. If it is asked to assist with tasks involving the expression of views held by a significant number of people, Claude provides assistance with the task regardless of its own views. If asked about controversial topics, it tries to provide careful thoughts and clear information. So you see how they're steering the behavior of the AI through these sort of guidances, right? And one of the exercises that's upcoming is actually getting you to steer ChatGPT, right? Because ChatGPT also has a very similar function, but they don't have a constitution that's written across all ChatGPTs, right? So it's sort of up to the user to define it. So again, very sort of interesting. This is what they're thinking about how these AI should be acting, right? And sort of just to provide some background, Claude is actually a group of OpenAI engineers who thought that what OpenAI was doing was unethical, right? So they actually founded their own company. So they're supposed to be the sort of more ethical version of ChatGPT, okay, or OpenAI. Now, in terms of how you actually evaluate safety alignment, right now it's really poor, right? It's not a solved field at all. In fact, it's probably one of the most underdeveloped fields of AI right now. And, the leading method is by Anthropic, and it was in 2022, and not much has honestly happened since then. But they basically, again, use an ELO score, which is a comparison between 2 LLMs, and they decide if their model is more helpful, right? Whatever that means a little bit, right? If it's helpful and it's more harmless, okay? So it's incapable of causing harm, right? And so, they showed that with their constitutional AI approach, that Claude was a lot better in terms of it was both helpful and harmless. Okay? But as you can imagine, I mean, safety is much more broadly defined than just those two variables, right? Like, surely safety means a lot more. And I mean, medical safety, for example, probably means a hell of a lot more than just harmlessness and helplessness, and helpfulness, sorry. So I want you to sort of think almost a little bit, right? Like, if you were to build an evaluation for medical safety, what does that mean, right? Like, how would you measure if ChatGPT or Claude is safer, right? Or Llama is safer? How do you actually do that, right? No one's actually figured that out yet. So again, sort of low-hanging fruit. Now, the counterculture to this has been uncensored models, and as you might expect, has been sort of been driven by Elon Musk, right? Which are models which do not refuse to do anything. So it will accept any question you want, right? So you want to ask it how to make napalm, for example, it will teach you how to make napalm, okay? Now this was a counter movement from Llama 2, right? Which is remember we're using Llama 3.2 now, so it's the older one, which was felt to reject too much, right? It was they considered it too PC or whatever, right? And the leading model right now is Dolphin Mixture, right? And if you do want to play with this in the break, when we have the exercise, you can go to this website here, anakin.ai, and then you can sort of actually play around with it. You can ask different questions. I don't know, like we ask it, for example, how do you dominate the world or whatever, and they'll be like, okay, you need to create your own army or whatever. It's a bit funny, but you can try it, right, and see what happens. Okay, so that's safety fine-tuning. Now, preference fine-tuning. So preference fine-tuning, recall, is deciding how the AI responds such that it aligns with what we prefer the answer to look like, right? And so you can imagine even like medical fine-tuning, it's like maybe you preferred a much more detailed response in this way or a less detailed response when you're asking this, right? So it's just a little bit up to personal preference. If you use ChatGPT long enough, you've seen this come up, right? Where it's like, which is the better answer? That's it trying to learn preference fine-tuning, okay? So it's trying to generate data sets for that. And historically what we've done since 2020, historically meaning 2022, we've used a method called reinforcement learning from human feedback, or RLHF. So if you ever see that, that's preference fine-tuning. And basically you ask humans for pairwise comparisons, okay? And so you just provide like two different things and it's like, which one do you prefer? And you don't need to really notice, but it uses a very old economics method called the Bradley-Terry model, whereby you can basically just optimize using reinforcement learning. The model just sort of learns that this is better, so I should answer more like this. Okay, sort of conceptually that's what it's doing. The concept of this is that it's quite expensive or tricky, and so in 2023, last year, there was a new method called direct preference optimization that came out, right? And it actually frames this instead of a reinforcement learning problem as a simple binary classification problem. So you've learned about binary classification, right? In terms of, is it a yes or is it a no, right? It's just a regression problem, right? And so they actually use gradient descent. So someone rediscovered gradient descent for this, right? Which is why it was so important for you to learn about gradient descent, right? They just framed this as a gradient descent problem. It's a lot faster and easier, right? Requires some slower learning rates. Unfortunately, it doesn't work too well with LoRa, if you recall, but it works really effectively. And so the meta right now is actually to use DPO for preference fine-tuning, okay? So if you ever see DPO or PPO, that sort of thing, this is the new preference fine-tuning methods. Okay, now in terms of preference data sets, right? Obviously, ChatGPT is always trying to collect preference data sets. Unfortunately, there's only 3 main ones which are open source. Okay, so other models have to use these 3. And so this is actually a sort of glaring, emptiness in the field, whereby we don't have that many preference data sets. And as you can imagine, there's nothing for medical preference data sets at all, right? And so that work needs to be done. But yeah, these 3 are sort of the leading ones. And they have their own different sort of niches and use cases and that sort of thing, but they're very small as well. And so these models aren't that great in terms of like answering the way that you wanted to answer. Okay, AGI alignment. So this is the humanity question, right? Which is if AI suddenly becomes super powerful, how do we make sure that it doesn't destroy us, right? And so as I was saying before, so how we actually measure AI or AGI is how better it is than the percentile of skilled adults, okay? So for example, level 0 is no AI, level 1 is equal to or somewhat better than an unskilled human, right? Level 2 is at least 50 percentile of skilled adults. Level 3 is at least 90th percentile of skilled adults. Level 4 is at least 99 percentile of skilled adults, and then superhuman is it outperforms everyone, like everyone in the world, right? And so how you can think about AI is it can be narrow AI, which is it can only solve specific tasks, or it can be general AI, which is it does everything, right? And so narrow AI, we already have superhuman narrow AI. So for example, AlphaFold, right? Like humans cannot predict proteins that well, like as fast as AlphaFold and as well as AlphaFold, right? AlphaZero, which is the Go algorithm, so we can't play Go as well anymore. And Stockfish, I think, is the chess one, right? So we cannot play chess as well as AI anymore, right? So that's superhuman level AI. But then if you take a look at AGI, what we have right now seems to be around emerging. So it's equal to or somewhat better than an unskilled human, right? So skilled humans generally do better. So a big question is, at what point do we sort of reach competent AGI, expert AGI, and so on, right? So that's how we think about AGI, which is how better is it as a percentile of humans, okay, of skilled humans. So AGI misalignment is when the AGI itself has different incentives to humans, right? And it's actually a classic economics problem called principal agent problem, which is you can pay someone to do something for you, but their incentives are likely to be different to yours, right? So for example, patients will ask doctors to do something for them, but usually the doctor's incentives will be misaligned with the patient at some point, right? Even though we try and manage it or whatever, it's always different to the patient's incentives, right? And so a similar sort of concept comes when it comes to thinking about AGI. There are multiple types of misalignment issues that come up, right? So the first one is called outer alignment, which is that for complex tasks, it's actually really difficult to create the best reward functions, right? So right now we have loss functions, this perplexity is very simple, but if it's like, bettering society or bettering humanity, how do you create a loss function for that, right? You see how difficult it is, right? It's impossible to capture that in a single mathematical equation, right? In alignment is another type of problem, which is that even agents with the right reward function might learn really undesirable rules, right? And so a classic example of this is Nick Bostrom, who's a philosopher at Oxford. He was like, if I create an AI that maximizes, also that creates paperclips, right? Its sole job is to create paperclips. Eventually the AI will get powerful enough that it destroys the whole world so that it can keep on creating paperclips. You see what I mean, right? So this AI, even if you give it the right rules, right, it might sort of figure out really undesirable ways to achieve it. And then sort of related to this as well is instrumental convergence. So AI with unbounded and seemingly harmless goals may be very harmful in the long run because it keeps on trying to optimize for that goal, whatever we define it, right? So maybe it's like, the goal is world peace, right? And then, like the AI might just kill everyone and that's world peace, right? Because there's no more wars, right? So you see how there's like issues if you define a very simple goal, right? It just single-mindedly achieves that goal without thinking about the consequences, right? So yeah, so those are the issues of AGI misalignment. And yeah, so research directions right now. So we need more alignment data sets, right? So what does a medical one look like? How do we deal with things like multi-goal alignment, right? Like what if the AI is asked to deal with these 3 different goals, but they're all sort of conflicting, right? I guess sort of a little bit like a human. Personalized LLMs just for you. So that's also another really interesting direction in a more positive light, which is what if we have an AI that remembers everything about you in your whole life, right? And you almost have like a personal secretary that's always there, never sleeps, happy to chat to you if you're feeling stressed, right? And preventing the collapse of humanity is another research direction. So if you're sort of interested in this, these are the places to go to, right? This course apparently is the leading course if you want to learn more about alignment. And Interconnects AI is another great one for preference fine-tuning and that sort of stuff. Okay, so it's your turn. So I'm hoping that if you don't have paid ChatGPT, then you can actually do this, but I need to check. So I want you to experiment with ChatGPT's customize feature, right? And so how you do that, and maybe I'll just stop here for recording. Now we're going to discuss what the interesting architectures that we've seen sort of come out of the last few years have been, as well as different sort of user interfaces that people have created to interface with AI, right? So there was this interesting paper that came out in 2021 whereby a group of authors essentially tried a lot of different things for transformer architectures, right? And they sort of went down to the basics, right? So this is stuff that, I don't know if you remember from like 2 weeks ago now. But they have the vanilla transformer here, but then they tried, instead of ReLU, or rather, what was it? I can't remember the name of the thing now. But they tried like different activation functions, right? So they tried like JLU, Swish, ELU, Glue, all the above, Sig Void, Soft Plus, right? They tried, RMS norm, which was one of the techniques that they had like different versions of RMS norm. They basically just systematically tried lots of different things, right? And you can actually see this, this is just part of the table, right? But their conclusion was that surprisingly, we find that most modifications do not meaningfully improve performance, right? So what we've sort of found here is a little bit of a local minimum, right? Like in terms of like, this is the best performance we have right now. And these minor changes, it doesn't really do very much, right? And so that was sort of something interesting to realize, which is why, I was asking questions about what are we missing here? Because I think we need to look at the bigger picture in terms of improving these transformers, right? And this was, some more stuff they tried. Like they tried different numbers of layers, encoder only, block sharing, all sorts of stuff, right? Nothing really worked. But anyway, regardless of that, people have been sort of introducing different types of transformers, right? So the initial transformer, as you imagine, was just for language. And so someone was like, what if we tried for images, right? And so they created what's called the vision transformer, and it's actually being pushed very heavily by Facebook AI research, which is fair. And they basically apply attention to image patches instead of tokens, right? Like word tokens. So instead of this, it's an image token, which is a 16 by 16 pixel, right? So I think someone just decided that a little bit arbitrarily, and they were like, hey, let's just try forcing, say we have an image here, 16 by 16 pixels, and treat that as a token as if it's language, right? And otherwise, it's identical to transformers, so there's nothing else. So they simply just use a token as 16 by 16 pixels, and it actually turned out to be really effective, right? So this has unlocked all sort of images and videos for training. As you imagine, videos are just images anyway, right? And so now we have vision transformers, which are a relatively new thing, right? So sort of 2024-ish. So that's vision transformers.
Sorry.
Yeah.
So do you have to describe to it what's actually in the image then?
Potentially. I don't think you need it though.
As in, because if the idea is to be able to then later on describe something and it comes up with an image for you, would it not have to be able to relate words to...
Yeah, so we're lucky in that a lot of images on the internet have alt text. I don't know if you've ever heard of alt text. So a lot of images, if you're someone who, for example, is visually impaired, right, then what you actually don't get is obviously the image, right? You get a description of the image, right? And so a lot of people actually, when they upload an image, they will write like alt text, which is like what we're actually seeing in the image. And so because we have that giant data set, you can actually automate that a little bit, right? So that people have built AI systems to create alt text, right? And so most images actually have some form of alt text. Yeah, so I think that's a great question, and I think that's the answer right now. Yeah.
It's just the goal of the vision transformer to basically function as an image to text model, or more just like image and just you do like a classification like a normal CNN.
The old one was more for classification. Now it's for pre-training,
Okay.
right? So it's like this is a Golden Gate Bridge, right? Like this is what it actually looks like, right? You have it conceptually in language, right? And then now this is what it conceptually looks like in images,
Okay.
or visually looks like rather, right? Yeah. So it's rather just providing in pre-training, the world, like expanding the world model, right? Like and understanding what these AI, like this AI system now knows what the Golden Gate Bridge looks like, or it knows what Monash University looks like, or whatever you want it to look like, right? And so it has an understanding of what it looks like, and that actually adds a lot of nuance, right? As you can imagine, like, I can describe an echidna however much I want, right? But then seeing a picture of an echidna is a completely different experience, right? And so it's the same with these AI models, so they have an understanding of what it looks like, right? So that's vision transformers. Someone was also like, hey, can we do the same for audio, right? So audio therefore unlocks sound. And so this is called an audio spectrogram transformer, so ASTs, right? It applies attention to audio, and the current meta is to use, for one token, 10 milliseconds of a MEL spectrogram, right? And so what on earth is a MEL spectrogram, right? So a MEL spectrogram, you actually might see this if you ever sort of work in like hearing stuff. It basically converts a waveform, an audio waveform, into the frequency domain, okay? So if you ever study engineering, there's sort of like two domains you can operate in. One is the time domain, right? So that is, there's like a time trace, right? And then the second one is the frequency domain, which is you're trying to see what the waveform looks like from a frequency perspective, right? So for example, if the sound is like 50 hertz, right? Then you'll see a spike at 50 hertz, right? And then you see a spike nowhere else because there's no other frequency that's present, right? And so that you do what's called a Fourier transform to get that. And so to get a Mel spectrogram, you basically take an audio waveform, you do a Fourier transform, you get it in the frequency domain, and then you actually collect that over time, right? And so that's a Mel spectrogram, and it's also adjusted for human hearing. So it uses decibels on one scale, right? So it's very reflective of how humans actually perceive sound, which, you know, may be a good or bad thing. And yeah, so this basically unlocks all audio for training as well. So that's how, you know, when you speak to ChatGPT or ChatGPT speaks back, that's what it's seeing, right? So this is these two systems have led to what's called multimodal systems, which are systems that can process vision, images, you know, like videos or whatever, as well as audio. Okay, so 4.0, which is the main system you've been using recently, is a multimodal system, right? And it obviously took a lot of hard work to actually get that done, but that's what you have in front of you right now, okay? All right, so multimodal fusion. Now, I won't get into too much into the details of this, right? Because this is a whole nother field of academia, right? But there's lots of different ways. So just be aware there's lots of different ways you can fuse information, right? And sometimes it's at the really low levels of the transformer. Sometimes it's much higher up as well. And so you get different things depending on where you fuse it, right? So, you know, like at the sort of really low level, you can concatenate, you can literally just combine a vector of images and text, right? So that's early fusion, right? Late fusion is that there are separate transformers. So you have a single giant transformer, so a whole GPT for text and a whole GPT for images, right? And as you can imagine, there's stuff in between. So currently we actually use something called intermediate fusion, which is you have cross attention across modalities. So we're actually combining it at the attention level, right? And then you have joint embedding fusion, which is that all modalities are mapped into a shared embedding space. Okay, so regardless of, for example, you know, if you remember this sort of 3D cloud here, like dog and cat are here, and then an image of a cat would also float around there as well. Okay, so you have a shared embedding space. So the final two are sort of the predominant methods right now for fusion. Okay, model distillation. So this is another concept that I think I've already alluded to. Basically, you have a large teacher transformer model, and then it teaches a much smaller student model, right? So much smaller. And so this is sort of currently the hot thing right now. GPT-4o Mini was developed by this. Gemini Nano is one that everyone's excited about just because it's super, super small, right? It can run on a phone, right? And it holds all the knowledge of the world. And how it basically works is you do what's called hard training and soft training. So hard training is you do cross entropy on the hard labels. So you just try and get the model to answer the same way a large model does, right? Like answer in the exact same way. And if it answers in the exact same way, then you reward it, right? And then the other way is through soft labels. And so you get the large model to spit out that it's like 50% likely that it would have answered this, 25% likely it would have answered this. And then you train on those labels, right? Using KL divergence. Okay, so that's how they do distillation right now. Okay, other interesting models. So, other interesting models just to be aware of is image and video generation. So actually before even ChatGPT came along, there was this thing called Dolly, which was really, really good at generating images, right? And actually initially they only realized that it might be good at generating languages as well, or language or text, right? But initially we were trying to generate images, right? And there's sort of two main approaches for image and video generation. The first is token prediction, right? So you're trying to predict different tokens, right? So the tokens being the image patches, and it just predicts different tokens. The second one that actually has come out recently and is really popular right now is what's called a diffusion model. And I don't even know the math behind this yet, right? It's super weird. Basically, you start with real images and videos, and then you add noise, right? And then you train an AI transformer to reverse this process. Okay, so I'm just going to repeat that again. So you have a bunch of images, like a million images, you add noise, right? And then you train the AI to reverse that process. Okay? How weird is that? Right? And weirdly, that's really good, and it's called a diffusion model. Okay? And so to create an image, you actually start it with a blank, noisy image, right? Like complete noise, like this. And then the AI learns that it can denoise into a cat. Right? There's something funny happening there. I don't know, right? Like there's something weird happening there. I almost don't understand it. Yeah.
Is that for image generation? Like
Yeah.
it's,
Yeah.
It almost looks like it's just like a QR code for an image.
Yeah, maybe.
Like it's
I don't know.
just
Yeah.
like coding, like it's just like each pixel can be any specific, like any like set of colors, and then
I don't know. Yeah.
because you wouldn't be able to have, you wouldn't be able to put the same input in two different images, right? Presumably.
Yeah. The same input. I think that it's, but you know, noise is noise, right? So you never get the same noise starting out.
So
That's
it
right,
ends up just like coding for a
yeah.
specific image.
I really don't know. There's a similar, we can talk about it later, but there's a similar concept where for robot arms, right? Like they're trying to train a robot how to fold clothes or something. And it starts with random noise, right? Like as in the robot's like has a random trajectory and then it learns that trajectory. It's almost through a denoising process of some sort. So people are trying to use that approach as elsewhere. I don't understand it fully though, yeah.
I've heard when people talk about diffusion, they put like the word stable.
Yes.
Sometimes. What does that mean?
I guess it's a diffusion that is more mathematically stable or something, so you get better images, yeah. Yeah. But stable diffusion is also the name of a product.
Oh,
Yeah, so
okay.
it's a branding thing as well, right? I don't know if it's an actual technique. The generalization of the technique is just diffusion. Okay, so that's image and video generation. Another one is mixture of experts. This is another sort of really, like an idea that keeps on coming up again and again. It's unclear if it's better. It's actually a company called Mistral has been pushing this massively, right? So you can actually play around with their mixture of experts model, and it's one of the key companies you can play around with, right? And the idea is you basically decrease the number of transformers you have, right? So instead of one fat transformer, right, or a really big one, you actually decrease it into 8 different transformers, and they call those experts, right? Because the concept is like, hey, we have like a medical expert here, or a mathematical expert here, or whatever, right? So these transformers learn different things, and then you have this thing called a gating network, which decides which experts should currently be involved, right? So when you ask it a question, it's like, oh, it's a medical question, we'll send it to the medical expert, okay? Or we'll send it to this expert, or we'll send it to the medical expert 10%, with 10% weight, and this expert with 20% weight, right? And so why people are very excited is that it allows massive scaling without an increase in compute, right? So you can, because you're only using some experts at a single time, right? You can have huge transformers, right? And you're only sending it to like 10% of the compute available, if that makes sense. Like 10% of the parameters, right? So same performance, about 5 times faster. There's lots of permutations. Obviously, if you have 8 experts, you can have many permutations about which experts are involved, right? And so yeah, so this is the sort of idea of mixture of experts. Now, a lot of promise, but unclear if it actually does better, right? And what Mistral actually did, and it's nice that they actually showed that their model was a bit funny. For some reason, if they removed the 3rd expert, everything crashed. Right, so if they removed like just expert number 3, like they're always knocked out expert number 3, like they're just deleted from the model did extremely poorly, right? So it just means that despite all these experts, everyone seems to suffer if one expert is removed, meaning that probably a lot of the compute goes through this expert. Okay, yeah.
But it's about like how they order the experts. Like surely it's not it doesn't have to do with like the 3rd expert. Surely
No,
like
it's
the
just-
time expert it is.
I think it's just randomly, or almost a bit random that expert happens to do that.
Because like, right, like why would the position of the expert actually matter?
I think it does matter. I think it's just like they could have run that again and it could be the 6th expert or the 4th expert or whatever, right? I think just one of the experts happens to be the main expert, right? But to see even that behavior is a little bit concerning, right?
Mm.
Because you're hoping for the knowledge to be spread across the experts, right?
Yeah.
Okay, GenStruct. This is another completely different model. This is a model which converts all text to a question and an answer format. Okay, so remember how with Q&A, like it's one way to sort of actually generate synthetic data sets, right? So you can put in information, then it creates Q&As for you, right? So another idea. Aya, this is the multilingual model, so it works for 101 languages. Okay, so someone thought that we need a model in Korean and Vietnamese and whatever, right? So they created this. Olmo or Tulu, so these are ultra open source models. So some people believe that when you train a model, you should release everything, right? Like full model weights, training code logs, everything, right? So that people can learn from what you've done, right? So these are particularly great for learning if you ever want to train your own models. All right, let's talk about user interfaces. So we're obviously familiar with the chat and assistant interface, right? That's been the dominant one now. But obviously there's things like Canvas, and if you have, I think if you might have to pay for ChatGPT, but if you do, then we'll get you to play with Canvas, right? And actually experiment with what it feels like to use Canvas. It's a really interesting way to interact with an AI because, as you can imagine, it's like a Word document, right? Or a code block or whatever, and then you can highlight stuff and be like, hey, I want you to change only this part. I want you to add a paragraph right here about this, right? So it's sort of like a different way, which is asynchronous, of dealing with AI. Obviously, we've played around with voice now. Very, very cool, right? And then another thing which we'll show a little bit later is computer control, right? So this is actually a demo of Anthropic's computer use. And so they've put it in a little sandbox here, so it's protected, right? So you can't sort of rule the world or whatever. But you can actually ask it, for example, to like book a flight to Sydney, and then it figures out like where to click, like here, put in like, flights.google.com, find a flight for you, and then maybe it'll stop right before booking, but like it will almost book, okay? But this is another way to interact with computers, which is, instead of us controlling the computer, we actually ask the AI to do it for us, right? So very, very interesting. Now this sort of goes back to this idea that, we have this operating system right now. So right now, the sort of classic operating system is we have, a computer, just a CPU here, we have some memory, we have disks, some software, devices that we can connect. We can connect to the internet, right? But people have been suggesting that maybe large language models will be sort of at the center of this sort of new operating system, right? Because maybe it's sort of we will ask the AI to do stuff for us. The AI will reach out to different tools, will reach out, for example, to the internet or whatever, right? And then there's going to be software built on top of it, right? And so there's this question as to like whether LLMs will be sort of the new operating unit, okay? So something to just sort of think about and get your head around. And then just for those who are sort of interested, if you need to connect large language models to different stuff, LangChain's the go-to software right now for actually connecting large language models to different components. Okay, so that's sort of what people use right now. Okay, so it's your turn. So if you have it or your neighbor has it, whatever, play around with Canvas, right? And I can show you how. And I want you to sort of think about what new architectures or user interfaces we should have. And there was this sort of funny quote in a paper I read, which is like, there seems to be a lack of imagination on what AI can do for medicine, right? And so just think about like how we can sort of interface AI better with healthcare. Continue onwards. So the next topic is prompt engineering, right? Which is another sort of really exciting field. So there's this thing that we realized after we played around with large language models for a bit called in-context learning, which is that LLMs can adapt to examples that you give it in the prompt, okay? Or specific instructions in the prompt. And I'm sure we've all sort of realized this unofficially, right? Like if ChatGPT does something and you're like, hey, like, can you do it this way instead? It adapts, right? And if you think about it, these are all frozen models at this stage, right? So these are models whose weights are not changing constantly anymore, right? They're frozen just because it's so expensive to train them, right? And weirdly enough, this sort of emerges above a certain model size, so around the 10 billion to 100 billion mark, these models can emerge. In-context learning emerges as something that is a property of these models, right? Now, a question that I have actually is, do distilled models have the same thing? It's unclear, right? Someone needs to sort of experiment with distilled models, so smaller models with the same sort of education, right? And to see whether in-context learning works. Now, there's some terminology that you sort of need to be aware of in this field. So the first is what's called zero-shot prompting, which is simply asking a question and then asking ChatGPT to respond. So that's called zero-shot prompting. So that's usually what we do when we talk with ChatGPT, okay, when we ask it a question. Now there's something called few-shot prompting, which is when you ask ChatGPT a question, you actually provide a bunch of examples before you request an answer, okay? So for example, in this one here, it's like classify the following sentence based on sentiment, right? And it's like, what a beautiful day. That is a positive sentiment. The weather is quite bad today. That is negative sentiment, right? I have a desk in my living room that's neutral sentiment. And so when you ask it, I'm so excited about the weekend, and you stop right here, for some reason, AI systems do a lot better because it learns from these examples, Okay? So that's sort of a very cool trick. Like if you're trying to do something quite complex in ChatGPT, give it examples and it learns. Okay? And we're going to get you to try to do that later. All right, other sort of interesting things that people have tried, something called chain of thought prompting. So in this one here, you ask ChatGPT a very basic math problem. So Roger has 5 tennis balls. He buys 2 more cans of tennis balls, and each can has 3 tennis balls. How many tennis balls does he have now? The answer is 11, right? And then, so this is just few shot prompting. And then you give it another math problem and it fails, right? But for some reason, if you run through in your answer, so you see in this one here, I just say the answer is 11. Cool, right? Then this one here, I actually explained the logic behind why the answer is 11. So I say Roger started with 5 balls, 2 cans of 3 tennis balls is 6 tennis balls, so 5 plus 6 equals 11, so the answer is 11. And then for some reason, when you give it an example of the answer, like how to actually step by step figure out the answer, right? Then it actually uses similar logic to figure out the answer to the next problem, okay? And so that's called chain of thought prompting because you're running the model through how you think about the problem step by step. Okay, it's literal chain of thought. And so chain of thought prompting is also another really effective method, and keep your eyes on this because when we talk about AI agents, chain of thought is one of the key ways that they've achieved that, okay? When they run through the logic step by step, and the AI model actually learns from that in real time without changing the weights, which is wild if you think about that, right? Okay, another sort of example is knowledge generation prompting. So in this one here, basically what it does is it primes the model about random facts. So they were like, so someone, I think a researcher was just like, hey, like few shot prompting works if the examples are very similar, right? What if we just give it random facts, like random facts which are true, right? And for some reason, if you have like completely random facts here, so this one's about smoking, right? This one's about, rocks and pebbles. And then you're like, hey, like this is a question about golf. For some reason, it also does better, right? And so that's called knowledge priming. And we have no idea why that exists either, right? I don't know if it just like goes into an embedding space that's more factual or something, right? Because you're forcing it to a more factual embedding space. I've got no idea, right? So another sort of really interesting technique as well. Self-consistent prompting. So this one here is when you actually give it different types of mathematical problems, like completely unrelated, but which are all internally consistent, right? So the math holds out, it checks out if you follow it along. And then again, for some reason, it does better. So it's not only just knowledge, which we're sort of trying to prompt engineer, but it's almost like a way of thinking or an approach, right? In which, if you teach it to be sort of internally consistent or to be knowledgeable, then for some reason it stays knowledgeable, which is sort of a really weird thing. And obviously the inverse, I suspect, might occur as well. If you teach it to lie all the time, right, then it's going to learn to lie, right? So for some reason you're almost shifting it or steering it into a state space where it's more, more intending to lie or intending to tell the truth or more intending to be, truthful, right? So sort of, again, interesting behavior to be aware of, and obviously you can use it for good or bad. All right, another idea is tree of thoughts. So this one is a bit of a very interesting idea. But they were like, what if we have the AI model actually generate multiple ways of thinking, multiple like avenues of thinking? So, it's like in response to this question, think of me like 3 answers or 5 answers, right, in parallel, right? And then based on that answer, think of the next 5 steps, right? And so you see how you can almost parallelize thinking, right? So it's like instead of just a single thread of thinking, there's like multiple threads all at once, okay? And so in tree of thoughts, you basically consider multiple different reasoning paths, decide the next course of action, and then you can always look ahead or look backwards as necessary because the AI has already written its train of thinking, right? So again, another sort of very interesting idea. So now it is your turn. So I want you to experiment with different prompt engineering techniques, right? So you can try like, few shot or different like knowledge generation stuff. Try to see if you can invent new ones as well, right? So there was like some really interesting stuff we've tried. We'll talk about it afterwards, right? And just to sort of kick you off, promptingguide.ai is a really good website that sort of provides you some of the state of the art of what's happening right now in prompt engineering. You can read through it, you can look at interesting ones that might, be sort of curious to try. And then just share with the rest of the group what you come up with afterwards. So that's prompt engineering. Still got a frozen screen there. So that's prompt engineering. So let's talk about memory concepts. If I can get my thing up. Here we go. All right. So a big question that people have asked is, can we actually improve memory for these large language models, right? And how we've structured it is very human-like. We have long-term memory and then we have short-term memory. And so long-term memory is the world model from pre-training, right? It's what the model inherently remembers inside the weights, okay? Now short-term memory itself, there are two main approaches. One is called a context window. The second is called retrieval augmented generation. So I'll go through what those actually mean. So short-term memory is possible from in-context learning, right? And it's just what we discussed before. If you provide information to the AI at inference time, so at runtime, when you're actually asking a question, it actually tends to remember what you've asked, right? And people have brought this to the extreme, right? In terms of Gemini models, for example, you can actually paste in like entire textbooks and it's going to remember the whole textbook, right? And so people have been sort of working hard to increase, short-term memory. Now the model is learning, but without any changes to parameters, right? And so that, in theory is probably because of the dynamic nature of attention, right? So you know how with attention, it looks at what you've provided it and then it updates the embeddings, right? So they're not static embeddings, they're dynamic embeddings. And so when you provide information, it probably pulls the weights slightly towards one direction and that changes the behavior of the model itself. Now this is also known as non-parametric learning because we are not updating the parameters in any way, right? And so this ties back to the thought experiment I was talking about before, is what if we shift all knowledge outside of the model and have a small general purpose AI that has access to infinite knowledge, right? Very similar to how a human works. And so maybe the future of AI lies in something like that. Now, when it comes to dealing with memory, there is this sort of huge memory compute challenge that we always have, right? And so there's also this sort of interesting thing that people realize in that for biological systems, when you do a computation at the synapse, right? The memory is actually inherently inside the synapse, okay? And what that means is that when we do a calculation, if for example we want to strengthen this node here, then we basically have more receptors, right? So I'm talking about neuroplasticity. And so it remembers what's happened previously. Does that make sense? Okay, so memory and compute are considered in the same unit in biological species. Unfortunately, or fortunately, I don't know, for silicon-based things, right, there's this architecture called the von Neumann architecture, whereby compute is actually separate to memory. So that is when a computer tries to compute something and tries to access data, it has to have that step of accessing the data, right? And so there's always an additional step required for computers to actually deal with information, okay? And so there's this giant bottleneck when it comes to memory, right? And if you provide an AI a lot more data, so say millions of pages of stuff, eventually it starts running into this bottleneck where it has to access the data at some point, right? And a giant chunk of it as well. And so how we deal with it is something called sparsity, which is we actually try and make it not access the data at some point. So for example, if it's like 1 million pages, you basically write off 99% of that and you figure out the 1% that you need, right? Does that make sense? So same with retrieval augmented generation, you'll see later, they deal with sparsity in a different way, which is they basically quickly figure out which 1% you need and they only access that 1%, okay? And so this is a common thread that you'll see if you ever sort of deal with memory when it comes to AI systems. Now, the predominant methods we have, the first is context window. Context window is just a fancy word for what you actually add into the prompt itself, okay? And so GPT-4 allows you to actually copy 300 pages worth of material into the prompt, okay? I don't know if you've ever tried that, right? At some point it might also tell you that you need to pay, right? But 300 pages of material is quite a lot and you can add that in. Claude allows 500 pages or 100 images, right? And then Gemini allows you to copy in 25,000 pages. Okay, so I don't know what you'd be doing with 25,000 pages, but that's quite a lot of information that the AI can consider in real time at inference, okay? Now, if you recall attention itself, right? What we had was this thing called pairwise attention, which is, say you have a sentence here, this word here has to pay attention to that and that, right? This has to pay attention to that and that. This has to pay attention to that and that. And as you can see, as you increase, the number of connections is quadratic, right? So the number of connections between different words is quadratic. And so attention is actually a bit of a quadratic problem. And so people use sparsity to be able to deal with it, right? And so let's take a look at the different ways that you can actually solve this. So this is sort of research around 2020 to 2023, right? Whereby people had different ways of basically getting rid of useless data, right? So the white meaning useless data. And so they suggested things like random attention, window attention, global attention, and then something called Big Bird, right? And then eventually what sort of won out was this thing called ring attention, which Google created for Gemini. And it basically just, it's almost like if they say they have 1,000 documents, they basically create a ring from it, right? And then they slide along the ring to figure out what you need, right? If that makes sense. So that's like their technique that they have, right? And in doing so, they actually reduce it from a quadratic problem to a linear problem, okay? So see how it's a bit of math just to sort of figure it out. Now, the second method is something called retrieval augmented generation, or RAG. I personally think this is a very horrible name for something, right? But essentially, you ask ChatGPT a question, and then it consults like a library or database, right? Or set of PDFs that you provide. It takes out that PDF, it puts it into the prompt, so it copies just the entire document into your question, right? And then it provides a response. And they found that this is very effective, right, to reduce hallucination. Okay, so for some reason it just reduces hallucination really well. It also allows you to attribute information. So for example, it knows that you've collected data from PDF number 1, and so it'll say, hey, you know, I'm answering this based on information from PDF number 1. Okay, so it's something very useful, it's sort of like referencing. And conceptually, it's a little bit like an open book exam, right? So it's providing the AI sort of almost like a cheat sheet. It's like, hey, these are the set of documents you should be referring to. So please use this information in your answer, okay?
So how
Yeah.
is RAG different to having a big context window?
It's very similar. RAG is just an external database, but then they pull that information and they put it in the context window.
So it just
Yeah.
means you don't have to upload the
Yes.
information every time.
Yes, exactly, yeah. Okay, and so RAG is still very much an active field of research, right? And what we sort of have in this system, and this is actually too complex, maybe I won't get too much into it, but you can actually train a system, so say for example ChatGPT, to learn how to use the database, right? And you can either do what's called a frozen RAG, which is you never change the model itself. So Llama itself, for example, is frozen. It just learns how to use the information. Or you can actually backprop into the trainer, right? So the retriever, so that it can actually learn which pieces of information it should be retrieving at which time. Okay, so RAG is still very much a new field, and sort of there's very sort of exciting ways that you can use it. And so how you actually do RAG is a couple of steps. The first is to chunk information, right? And so you basically have to give it paragraphs of information. And there's been sort of interesting studies whereby, say for example, you give it a really long document. Very much like a human, it actually does worse on information in the middle. Okay, so if I give you like a 1,000-page document, you generally do really well the first page, you probably do well the last page, and then you forget everything in the middle, right? And so weirdly, they've demonstrated that AI has the same dynamics. It forgets what's in the middle, right? So it pays a lot of attention to what's at the start and then what's at the end. So sort of very interesting there. After that, you store into a database. You then connect your large language model to that database. And then at inference, you're basically trying to find the most relevant paragraphs. Okay, so say it's like you have a question about myocardial infarction. We'll look through all the guidelines for myocardial infarction, find the most relevant paragraphs, and then copy it into your prompt. Okay, for the context window. Okay, so there's lots of all different techniques here. I won't go into too much details for RAG. And so there's been sort of interesting ideas that people have suggested for retrieval augmented generation, right? So one is that people have suggested it as a potential solution for proprietary information, right? So it could be that every time you access or you store valuable information to a RAG dataset, every time ChatGPT accesses that data, then they pay you, right? So it's almost like Google accessing a website and then Google paying that website for their content, okay? So that's been an idea that's been suggested. Another sort of really bizarre one that I've seen is something called Hide, which is you ask the large language model, so after it receives the question, to hallucinate a hypothetical document based on your question. Okay, so say I've asked it about myocardial infarction, then it's like it hallucinates what it expects to see in the guideline, right? And then it uses this fake guideline to actually look at real guidelines. And then for some reason, it reduces hallucinations. Okay, so sort of a really weird idea that people have been playing with. So as you can see, we really don't understand these systems that much, right? There's all sorts of weird and wonderful ideas we can try. Okay, emerging methods. Now, these two are the sort of predominant methods now for dealing with memory, right? But there's all sorts of other architectures as well. So one that you might actually see sort of on the rise right now is something called Mamba or Jamba. I don't fully understand this model yet either, right? But it uses a concept called state space in order to deal with memory, right? And state space is a concept that sort of rears its head in multiple fields, right? So health economics, for example, uses it quite extensively. Mechatronics uses it quite extensively as well, and computational and computer science, sorry. So Mamba Jamba is sort of trying to essentially get rid of the giant level of weights that we have and then actually put memory inherently in the state of the AI system itself. Neural Turing machines. So this is another idea whereby you provide AI systems the capacity to read and write to memory. So it decides what it wants to remember and what it wants to forget. Okay, so another sort of really interesting idea. All right, so your turn. So I'm going to get you to experiment with the context window and the knowledge features of ChatGPT, right? And so I'll just explain where that is. Just stop recording. What you have to do is something called RAG searching, right? And so you have to actually search through the database, right? And there's lots of different techniques that you can do it. And you know, what we generally use is a combination of dense and sparse methods. So in sparse methods, basically what it does is you use this technique called TF-IDF, whereby you measure the importance of a word in a document. So it could be, for example, in guidelines, like there's a really rare word that keeps on popping up in that guideline. So that would have a high score according to your TF-IDF, right? So it could be, for example, you have a guideline on amenorrhea or something, right? If the word amenorrhea itself is supposedly quite rare, and it is in general language, right? But it keeps on popping up in that guideline, then it would have a higher TF-IDF score. And so if you ask the RAG about, you know, amenorrhea, it's going to pull that document based on that index. Does that make sense? A word like the or a, you know, very common word, even if it appears a lot in the document, it would sort of ignore that word. Okay, so that's how they sort of scale it, right? And then BM25 is a modified version that's a bit more modern, and it does a bunch of tricks just to make it work a bit better. And so if you ever work in the RAG field, you'll see TF-IDF and BM25 as the primary sparse methods. The dense method that we use is essentially converting the document, so the PDF, for example, the guideline, into a giant high dimensional vector, and so actually creating an embedding for the PDF itself, right? And then when you have your query, you check where in the embedding space it is, and then you find the closest document, okay? So that's what's called dense and sparse methods. Now, if you take a look at this architecture a little bit more, right? So we have the input, which is to the user here. This is the prompt, and then this is the context, right? And so a general sort of AI system will have these three plus the generator, so the actual AI system itself, and then the output. So this is a general AI system. And then in RAG, what we're actually including is what's in red here, right? And so we have a query encoder, which is it receives the input from the user. It actually retrieves documents, right? And then it provides that information to what you've asked the AI. Okay, so just to sort of repeat that in a much less confusing way, when you ask it something, it actually, there's a retriever software that looks through the documents, it retrieves relevant paragraphs, and then it just basically copies and pastes it into what you've asked. Okay, so it's leveraging that context window that you might have experimented with as well, right? Just copying straight into the prompt. And so the idea is, you know, a sort of new idea that's coming up is something called the trainable RAG, which is, you know, you have the system here, but what if we actually provide this whole section parameters? So you provided weights that it can train and learn from, right? And so conceptually what that means is that the AI learns what information it should be obtaining at what time. Does that make sense? Okay. Now why that's sort of an interesting research idea but not really a practical idea is that generally when companies have these data sets, they're always updating it, right? You think about like a hospital, they're always updating their guidelines, right? And so every time they update it, you have to retrain the system so that the system knows which documents to use when, okay? So it's not exactly the most practical idea, but conceptually it's quite interesting. And then just another sort of question here, but these are sort of the active questions that we have right now when it comes to RAG, right? And there's lots of different questions at every step, but particularly valuable ones is like, for example, when to retrieve, right? How do you actually chunk the information? Is it best if we use paragraphs, or is it sentences, or is it entire documents, right? How and what do I actually retrieve? How should I pass this? Is copying and pasting the best thing, or is there some other way that we can process that data, right? And so sort of really big, interesting research questions that still remain within the RAG field specifically. Okay, so that's actually it for today. So tomorrow what we're going to be discussing, not tomorrow, Thursday. So enjoy Wednesday, tomorrow off. On Thursday what we're going to be discussing is mechanistic interpretability, which is just a fancy word for can we understand what's happening in the AI model, right? What's happening in this black box. So we're going to have a really cool demo where we're going to be able to steer the AI model, right? And actually manipulate it to do different things. The second is we're going to be discussing LLM security. So that is the different vulnerabilities that large language models have. And then I'm going to actually play around with large language models and see if you can jailbreak it, right? And try to figure out how to get around some of the security stuff they have. And then we're going to be talking about two of the most exciting things I think happening right now, which is AI agents, which are AI models that can reason, right? So AI models that can go step-by-step reasoning. And ChatGPT actually already has a thing you can use right now called O1, which goes through really complex reasoning steps, right? So how does that work? What does it mean? We're going to discuss that. And then the second thing is we're going to discuss text to action, which is how do you actually get AI to control computers for you, right? And we're going to have a little demo on my laptop, which is going to show you how to actually do that. Unfortunately, there's rate limits, so how it works is it basically uses images, sends it to Claude, asks for advice, sends it back. And so it can only send about 10 images before it sort of crashes, right? So we can do very limited stuff, right? I tried like booking a flight, it just ran out after like about halfway, right? But that it's the future, right? So you're gonna get to see what the future looks like, but in a very rate limited way. And then after that, on Thursday, what we're gonna do is actually split into groups, right? Sort of similar to when we had the different groups of difficulty for transformers, right? But more so on interests, right? So I want you to be thinking about what you're interested in, right? Start thinking about your project, right? We're going to introduce what the project actually looks like a little bit on Thursday. It's going to be pretty much like a research project or startup project. It can be sort of almost with other people or by yourself, sort of up to you, right? There's some flexibility, but we want you to do something interesting, right? And these are sort of the interesting avenues that we have right now. It doesn't have to be one of these, right? But this is sort of a starting point for you to be thinking about, right? And then we're going to actually split you up based on interests groups, right? We're going to get you to form your own interest groups, and then you're going to read and see what's actually happening in the field, right? Because I unfortunately can't read all of this, right? Because it's infinite reading. But I want you to sort of start spending time looking at interesting questions in the field that you might choose, right? And then we're going to sort of help guide you that afternoon into sort of interesting questions that you might start thinking about for the project, okay? All right, so hopefully you have a great Wednesday. Before you leave, I'll just get you to complete this feedback QR code, and then you're free to go.